Okay, can I just confirm that I've already shown you all these answers? And what about the last two? Did I show you all the answers? Okay, please check your work. Now, does anybody need help for question 5? Okay, so let's see. Question 5 says the nth term of a sequence Tn. Tn refers to the nth term. So T1 refers to the first term. T2 is the second term, so on and so forth. So it is given that Tn is equal to negative 19n minus 3. Negative 19n minus 3. Which term has a value of negative 250? So T question mark over here equals to 250. We don't know. Sorry, negative 250. I want to find the value of n such that the term number, the term value is actually negative 250. Okay, so this being the general term is our rule. It is our so-called formula. When t is equal to 1, when n is equal to 1, our first term, we have negative 19 minus 3. So the first term is negative 22. When n is equal to 2, meaning I want the term number 2, I get negative 38 minus 3, which is negative 41. The second term is negative 41. At which point do I have the value equal to negative 250? I'm definitely not going to list down everything. I'm going to make use of this general term. I'm going to set it now to become negative 250. So when Tn equals to negative 250, because that's what the question was, yeah? When it's negative 250, we have negative 19n minus 3 is negative 250. Now it becomes a case of just solving for n. I am going to add 3 to both sides, resulting in negative 19n equals to negative 247. So now n must be equal to, we will now divide by negative 19. Okay, and where's my calculator? Negative 247 divided by negative 19, 13. So n is equal to 13. In other words, the term number 13 has a value of negative 250. Okay, so we say answer T13. Term number 13 has the value of negative 250. This is the presentation. The next question we have is number 6. Does anybody need help for 6? Huh? 5b? Oh, okay. Yeah, there's another part, 5b. 5b. Is negative 344 a term? Is negative 344 a term? Huh? Term means, okay, if I give you a sequence, a number sequence that looks like this, 2, 4, 6, 8, 10, so on and so forth. Do you see the pattern over here? Plus 2, right? Or you can just times multiples of 2, right? This is term number 1. Can you tell me what is term number 4 in this sequence? Huh? Term number 4. Yeah, this is term number 4. So now you know what a term is. No, the term refers to this value. Term number 1 is 2, term number 2 is 4, term number 3 is 6, term number 4 is 8, term number 5 is 10. So is negative 344 a term in the sequence? What does the sequence look like again? So we did a quick calculation earlier on. In our sequence for question 5, it is negative 19 times 1 minus 3, which is negative 22. Then we had negative 19 times 2 minus 3. We got negative 41, negative 19 times 3 minus 3. Negative 60, so on and so forth. This is our number pattern, isn't it? And when we go down to term number 13, we had its value equal to negative 250. So they are asking, is negative 344 found inside here? Is it part of the sequence? What do you think is the answer? Yes or no? How are you so sure? How are you going to convince me that it is not part of the sequence? You may be right, that it is not a term, but how are you going to convince me? It's not divisible by what? 19? Somewhere there, you got the correct idea. Okay, so to answer this very common question, this is the approach. So please look carefully. Is it part of a term for the general term Tn equals to negative 19n minus 3? To answer this, we will say, let negative 19n minus 3 equal to negative 344. Let's pretend that it is a term. Okay, so far? This is the logic, this is how we're going to do it. We pretend it is part of the sequence. What do you think I should be doing next? What can I do next from this step? There's only one thing you can do. Plus 3. Basically to solve for n, right? We are trying to find out which term is it. Okay, let's see what happens. Negative 19n equals to negative 341. I added 3 to both sides. Okay, so far? What should we do next? Divide by negative 19. We are trying to find the value of n. Okay, negative 341 divided by negative 19. Oh, look at what I got. 341 over 19. What does this tell me? This tells me that negative 344 is not a term. But do you know why? What is not a whole number? 341 out of 19 is not a whole number. Why is it that our friends are saying 341 over 19 is not a whole number, therefore negative 344 is not a term? What is the logic behind this? What must add up to be a whole number? What does n represent over here? It is the term number. Term number 1, term number 2, term number 3, this is term number 13, so on and so forth. We have a term n somewhere, and this is given by negative 19n minus 3. So term numbers must be whole numbers. You cannot have term number 2.5. You only can have term number 2, term number 3. You cannot have anything in between. Do you get the logic? You all get the logic? Who is following? Raise our hand. This logic. Okay, thank you. Put our hands. So because n is not a whole number, which is not an integer, so negative 344 is not a term. Okay? Now suppose the question says, is negative 250 a term of the sequence? What is your answer to this question? Is negative 250 a term in the sequence? Look back at your part A answer. Part A says, which term has a value of negative 250? So is negative 250 a term? Yes. We can confirm it by saying negative 250, let negative 250 be equal to negative 19 n minus 3, and then we work it out the same way. We find that n is equal to 13, which is an integer. So negative 250 is a term of the sequence. Okay, this is a very important logic that you must know. It will still be tested when you go to Sec 4 doing your O-levels. You go and flip go to Popular Bookshop, take the O-level 10-year series, you will find this question. Is this part of the sequence? So moving on to question 6. Does anybody need help for question 6? If yes, please raise your hand. Okay, no. Then moving on to 7. 7, okay. Express the n term of the sequence. Now we see that it is 8, 27, 64, 125, and we want the n term. Meaning, I need to know the sequence over here. Do these numbers look familiar to you? How are they? Harry, what do you see? What will you rewrite it as? 2 cube. Okay, so this is the same as 2 cube. Rian, what do you think this is? 3 cube. This is 4 cube and 5 cube. So on and so forth, right? So very clearly, we all know the pattern already. Question, which is term number 1? Which is term number 1 over here? 8. 8 is our term number 1. This is term number 1. This is the first term of the sequence. This is term number 2. Term number 3. Term number 4. Okay? The numbers that I'm going to be highlighting are crucial. Term number 1 is related to 2 cube. Term number 2 is related to 3 cube. Term number 3, 4 cube. Term number 4, 5 cube. The question is asking for term n. They want the n term. So what do you think n term will look like? Term n will be something power 3, isn't it? But what is that something? What is the something inside there? Is it n? N plus 1? N plus 1, right? You see, from 1, we get 2. From 2, you get 3. 3, you get 4. 4, you get 5. So we see the pattern over here. Whatever is this little number at the term, we just plus 1. And I cube the value. So this is n. Then inside this blank must be n plus 1. And this is my general term. Question 7 done. Question 9. Anybody needs help? 9. Okay. In a sequence, the first term is 17. This is term number 1. The next term is 4 more than the previous term. So plus 4, I get 21. This is term number 2. Plus another 4, I get 25. This is term number 3. Term 1, term 2, term 3. Okay, so we have the third term already, it is 25. Okay? Then they ask for the 10th term. Term number 10. Do you want to keep adding to find term number 10? Or is there a shorter way? And what is the shorter way? I will now introduce you a formula that is used for common difference question. Okay, these are common differences, right? What is the difference over here? 4. This is a common difference of positive 4. So this formula that I'm going to show you is applicable to common difference question only. It goes like this: Tn equals to T1 plus n minus 1 d, where d is the difference. Okay, so let's see what this actually means. Term number n is it has a value of term number 1 of the sequence. Term number 1 is 17 plus whatever this n value is. If you want the fifth term, for example, then this will be 5, and 5 minus 1. Today we want term number 10, so I'll write this as term number 10 is equal to term number 1, which is 17, plus, since I want term number 10, meaning n is equal to 10, 10 minus 1, 10 minus 1 times of, the difference is 4. The common difference d is for common difference, it is 4. So this gives us 17 plus 9 times 4, 36. Resulting in a value of what's this? 53. Okay, so this is the formula. Why does this work? We can go back to our original number pattern over here. Why does this formula work? When I talk about the first term, it is 17, right? Well, if in this formula that I'm giving you, if I want term number 1, n is equal to 1. Then here we have term number 1 is equal to term number 1. I cannot add anything to it already. Because if I add anything else to term number 1, I wouldn't get term number 1 anymore. So, in order for this to work, term number 1 must be equal to term number 1 plus 0. But how do I ensure that the formula returns in a 0? That is, if n is equal to 1 over here, minus 1. 1 minus 1 is 0. Whatever you multiply it by the difference, you will get 0. So term number 1 will still remain as term number 1. Let us move on to term number 2. Term number 2 is actually term number 1 plus 1 time of 4. Term number 2 is the same as term number 1 plus 1 time of the common difference, which is 4. Okay, so this is what we are saying. Term number 2 is term number 1 plus 1 time of the difference. 1 time of 4. How do I get 1 from term number 2? I just take 2 minus 1, I get 1. And so on and so forth. What does this actually mean for term number 10? For term number 10, we are actually getting it from term number 1, which is the 17. How many 4s do I add over here? There are 9 of them. There are 9 times that I am adding the common difference of 4 in order to arrive at term number 10. That is why we have this particularly very useful formula for common difference patterns. Only for common difference, yes? Do you have another method? Okay, what is your other method? Term 1 minus 4, and then? Okay, this is equal to 13, then what do you do? Okay, and in this case, when n equals to 10, 13 plus 4 times 10 is 53. And this is your answer, isn't it? Why does hers work? This over here is her formula. We can call it formula, okay? To her, Tn is equal to T 0 plus nd. It is equivalent to my formula of Tn is equal to T1 plus n minus 1 d. These two are equivalent. Why are they equivalent? I started off with term number 1, but I had to add on n minus 1 d. Okay, I look at the number of gaps in between. If I want a 10 term, there are 9 gaps over there. So 10 minus 1 times the difference. What Omera did was, she changed the pattern slightly. Remember I said this is term number 1? She found term number 0. Term number 0 is over here. This is minus 4, she gets 13. Term 0 is 13. When she does this, we look at the number of gaps all the way from term number 0 all the way to term number 10. There are 10 gaps over there, yes? Samuel for help check out. So based on her formula, instead of 9 gaps, she now has 10 gaps. So there are 2 approaches that will be acceptable over here. You can choose either one of these. Okay? Personally, I prefer the first one. The second one is absolutely correct also. Okay? But you will need to find out what term 0 is. Can? Okay, so that is question 9. One last question. Question 13. Does anybody need help? Nobody? Then how do you do part B? Huh? It's not a multiple of 7. What is our value for A? 1 over 1 over 7? Okay. So B is 7, C equals to 49, right? Is 1 over 7 part of the sequence? Is it part of the sequence? Yes, obviously it is the first. It is A, right? Is 1 over 7 a multiple of 7? Is 1 over 7 a multiple of 7? Is it? What exactly are multiples of 7? You got 7, 14, 21, so on and so forth, isn't it? And when I hear you tell me that 2020 is not a term in the sequence because 2020 is not a multiple of 7, it tells me that you probably checked the answer at the back, and that's what it said also, isn't it? Does the answer at the back say it is not a multiple of 7? Yeah, it does. How about we try what we did earlier on? Earlier on, when we try to find out whether negative 344 is part of the sequence, we had an approach. When I asked you, is negative 250 a term in the sequence? We had the same approach. Shall we try using the same approach? Let's see what happens. Okay, in order to do that, we start with 1 over 7. This is 1, 7, 49, 3, 4, 3. This is term number 1, term 2, term 3, term 4, term 5. Okay, and what is my term n? What is the pattern over here? Are these numbers familiar? Quite familiar, right? How will you rewrite 49? 7 times 7. In other words, 7 squared. How will you rewrite 343? 7 cubed. How will you rewrite 7? 7 power 1. What about this? 7 power 3, 2, 1. What is the next power here? 0. Okay, let me convince you. 7 power 0 is 1. Okay, so what do you think is the next one over here? What's the next power? What is 3, 2, 1, 0? Then what's the next value? Negative 1. Okay, so let's just check. 7 power negative 1 is 1 over 7. Yeah, we have it. This is the pattern. So let us find out what will be our general term for Tn. Are you able to tell what it is already? First, what is something that I can confirm about term n? What does it confirm have? 7. What is it that we need to find out now? The power. Okay, what is inside this blank for this power? What do you think it is? Is it n? Is it n plus 1? N plus 2? N minus 1? N minus 2? What is it? What is it going to be? How we confirm is by comparing this with this. We are comparing things that change. The number 7 doesn't change. So I know it's going to be 7 already. Let's compare all these things that change. Apparently from negative, from term number 1, the 1 over here, somehow I can get a minus 1. From 2, I will somehow get a 0. From 3, I will somehow get a 1. From 4, I will get a 2. From 5, I will get a 3. From n, what will I get? Is it clear enough now? N minus 2. Okay, so this is what we have. This is going to be 7 power n minus 2. Okay, now, if we let this be equal to 2020, then we are going to try and find the power. Our objective right now is to find a certain power for 7. 7 power something equal to 2020. Do you think it's possible? Do you think it's possible? Based on the answer key, we know it's not possible already because we will never be able to find a value, a whole number, an integer for n, then you minus 2, and you let 7 to the power of that to get 2020. Unfortunately, we have not learned how to solve this type of equation yet. We have so far only learned how to solve equations that are like this. And x minus 2 equals to 10, for example. We can solve this type of equation. But when the unknown is in a power, over here, we don't know how to solve it yet. To learn this, we will move on to Sec 3. In Sec 3, we will learn how to solve this, and we will apply this in order to determine whether this is going to be part of a sequence or not. For our Sec 1 standard currently, what we can also do is to use guess and check. Okay, guess and check a certain power of 7. We try and get as close to 2020. Okay, so let's guess when n equals to, for example, 10. We will have T10, term number 10 is equal to 7 power 10 minus 2, which is 7 power 8. How much is that? Too big. It's too big. 5, 7, 6, 4, 8, 0, 1. Obviously, I must go lower, isn't it? Cannot try T10 already. Let's try T5. Term number 5. 7 power 5 minus 2. Okay, that's not a good idea because we'll get 7 power 3. Let's try term number 6. So we get 6 minus 2, meaning 7 power 4. Let's see what we get. 7 power 4. 2401. We exceeded already, right? What happens when we have T5? Term number 5 is actually 7 power 5 minus 2, which is 7 power 3. It's 343. Between term 5 and term 6, it is 343 and 2401. 2020 lies in between. Therefore, 2020 cannot be a term. There's no such term. Okay? So this is another approach that we can use. Guess and check to try and see. And that's all for our homework question for this exercise 10.1.